Right, so let's continue the correlation program. So last class we just we just went through the slide and we discussed on the test and the function for the test. The test is called correlation. So let's run this in our R program. So open your R software and open a new R document and you call it as, okay, save. And today's class is Jan 31st. That's it. Okay. So the first line is always a comment. So author is your name, date, and the purpose. Okay. Then the next thing you want to do is we want to install this library, right? So I think I may have it installed. Okay, I don't have a library. All right, so what you do is we first need to install our library called ggpubr. And to do that, you have to just run the if statement from the first line. Okay, so let me try this running. Okay, so this is the statement which you need. So can you type in the statement on your script and also run it on your console? So it should take a couple of minutes to install the library called ggpubr. So do you have it installed? Yeah?
Do we do it again?
No, just once. So if you have it installed, then you don't need to reinstall it.
So it doesn't contact this system?
No. Yeah. So I didn't had it, so I just
So you did the normal, like you selected your plan.
Hmm?
I didn't see that I see it. On the what?
So this is giving me some error. When I copy this from the PowerPoint, when I try to run it here, it's some of the symbols, I guess these are not recognized by R. So what I did, I just Googled ggpubr library. I went to this page, ggpubr, and there is the same statement here, install statement. So I just copied this and ran it in my console. So there are some issues with, because if you there are sometimes you have this exclamation, right? And you copy this and put it in a PowerPoint or put it in a Word document, and then you copy and run it on your console, it will give you some error because when you copy paste things, the R is not able to recognize those symbols. Okay, so this is still giving me an error. Oh, you went from packages? Let me try that. Okay, let me try that.
You know what we did first? Okay, I think we only downloaded their tools. We did it line by line.
Okay.
By injection.
Yeah, let me try from the package if it will. And say when you do this, right? So you have this option. So always click this option, because if you don't click this option, then it will just try to install ggpubr. But ggpubr needs this additional package called tidyr, right? So this package may require some dependencies or additional packages. So anytime you try to install any of the packages from this package installer, then select install dependencies and then install. Okay, so now it seems to be installed for me, because it says downloaded packages are in folders. So to check, I'll just type in library ggpubr, and if it's installed properly, then it should load that library. Right? That's it. So you see, this is a different library, this is a different library. So in order to load or even install any of these libraries, it requires dependent libraries. So loading required this additional library called ggplot2. So for me, it's installed. So then what I'll make a comment, load the library. Next is we want to load the data. So I'll just show you what data we have. Load sample data. So in this case, what we have done is we just have loaded some dummy data, and the data is in this variable called empty cars. And this variable, it stores data when you install like it's an R inbuilt data, right? So when you downloaded and install your R software, so that software itself had this data set called empty data. And this data, if you want to check what it has, you can do like head of empty data. And if you do that, then you see like first few lines of your data set. And as you can see that it's a data frame because it has columns, it has rows. These are row names, right? So what do you think these are? What are these row names for? Do you what kind of data it is? Yeah, so these are different car names, right? So Mazda, Hornet, right? So these are different car names. And the columns are the properties of those cars, right? So for example, how much miles per gallon distance does it provide? Or how many cylinders it has, like 4-cylinder, 6-cylinder, 8-cylinder. Then how many gears does it have, right? So there are some car properties and the types of cars as row names. So if you want to look at the dimensions, right? So dimensions are just what are your row and column names. To check that, I just do dim my underscore data, right? So dim will give you dimensions of your data. So this data set, it has 32 rows and 11 columns, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it has 11 columns and 32 rows. And the rows, they do have row names, right? So these are different types of cars, Mazda, RX-4, RX-4 Wagoner, right? So these are different car names as your row names, 32 different cars and 11 properties for those cars. This is a sample data which you want to use for calculating our correlation test. So the next thing here is, as we discussed, we can calculate the correlation test in two different ways. The first way is you can plot it. The second way is you can just print your correlation value, right? So the first way is to plot it. So to plot it, I'll just copy the next statement and I'll make a note here. Plot the correlation value. Paste. Okay, so what I'm doing is I'm just using a function called ggscatter, and these are some arguments. I think the only argument probably you need is my underscore data, right? So even if you just give this one argument and just skip the rest of the arguments, you will still get a plot. Okay, but then here you are mentioning what should be your column names. You best fit line, you want to add the correlation method would be Pearson method, and then the X lab and the Y lab are just the X label and Y axis label. So I'll just run this plot on the console, and you should see this output. Okay, this is what you got, right? So yeah, so this is your correlation value. I'm not sure if you can see this, but This is where it prints your correlation value. And you have your x-axis as miles, and then the y-axis as your weight, right? So weight of the car, y-axis, then miles, x-axis, and you have the best fit line. So a best fit line is the line which tries to capture most of the points in your data set. And this is the spread of your data, right? And this is your correlation value. So what is your correlation value? Number, what is the value which you got?
Oh, yeah. That's 0.87.
0.87. Okay, so I cannot zoom it, but it should be same, 0.87. So it's plus 0.87, right?
No.
Minus 0.87. Okay, so what does that mean?
There's a negative relationship. So
What does that mean?
they're moving at different direction.
Right?
So they're moving at different. There's not like inversely. I don't know.
Yeah, there's an inverse relation. So what does that mean? Inverse relation, negative relationship. What does that mean in terms of x and y axis?
There's a significant
Significant, yes, that's correct.
relationship. However, they're not going the same direction, and it's like I said, it's like an inverse relationship.
Yeah, but can you explain me in terms of your x and y label, right? Okay, x-axis you have miles, and y-axis you have weight. So can you explain me in terms of weight and miles?
Okay, so in terms of weight and miles, I think the relationship would be maybe the bigger the weight, the lesser the coverage.
That's it. Yeah. Okay. Right. So that makes sense, right? So this seems to be a real world data, because there's a car and it has a weight. So more the weight, less the distance it will travel, right? So more the weight, less miles it will travel. Lightweight car, lighter weight, like Formula 1 car, right? F1 cars, they are lighter, so they travel fast. This makes sense, right? So more the weight of the car, it will travel less the weight of the car, it will travel more. So it's an inverse relationship, and that is what you see here. And it's significant, as I said, because it's 0.8, right? So magnitude is quite high, direction is negative. That's it. That's all it is. Okay. So have you saved this plot? So right, so you know, right? So you can click on File, Save As, and say call it as correlation plot. Desktop, save. So I have a PDF of the plot, and I'll have my Jan 31st R script. So these are two files which you need to upload on your Git. Also the R script, right? This file here. The R script also needs to be uploaded. So in the exam, right? So in the exam, if I give you, definitely you'll have one question on correlation. So I would ask you 3 things from this question. Okay. So this question would be like 25, 30 points. 25 to 30 points question. 3 things. First is I'll ask you to provide me the R script, your R program, right? This file here, right? Second thing would be this file here, the R script, right? You type in your R statements, you save it as, say, exam 1, and this is your R program, which I need to check, right? The second is your plot. Okay. And third is the correlation value and what does that mean. So in this case, correlation value is minus 0.8. That means you can say that when the weight of the car is more, the displacement or the miles traveled is less. So how do you interpret the result of your analysis? Three things. If you miss, like say plot, if you miss the R script, or if you didn't explain me what does your final result mean, then you will have some point deductions. Okay, that's it. Questions? Okay, so the next thing is we have made a plot and we have just printed our correlation value on that plot. The other way is to just print out the value without a plot. And to do that, I'll just copy this statement with call.test function. We go back, make a comment, just print the correlation value without plotting. Okay, so to do that, I just use another function and copy, paste, no error, and the value should be in res variable. You check it, and this is your core value, minus 0.8, same value. Okay. So what you have done in this function is you have just used a function called core.test, and you have passed 3 arguments. The first argument is which column you want. So we want a weight column. WT is the name of that weight column. The second argument is the second column. So in this case, we want miles per gallon, MPG column. And third is the method, which is Pearson. So if you go back to your data, then the first column name is MPG. The second column we want is weight, because you want to compare weight of the car and MPGs. And the dollar is the symbol for pointer, right? So you're trying to point to this column called weight, and the data is my underscore data. Do you understand this, right? This argument, the first argument. You understand? So what you're just trying to capture a column from a data frame called my underscore data, and to point, you just use a symbol dollar. It's different in Python, it's different in Ruby, but in R, you just use a dollar symbol. Okay. That's it. So then you run this and you store your correlation value in a variable called res, and you print res, and you see different types of information is provided, right? You get a p-value, you get degrees of freedom value, you get a confidence interval value. But for now, you just focus on this last value, which is the core or the correlation value, coefficient value, which is same as we did before, minus 0.8. That's it. Good. Questions? So far, you got this value? Okay. So now you go ahead and save, Control S. So you save the Jan 31st document, correlation plot, and you upload it on your Git repository. So once you do that, then I can have access to your Git repository, and then I can give you some points for that. Done? Okay, done. I did my upload on my GitHub. So for me, what I do is I go here, right? So I go to my GitHub here, and then I will look into the followers, right? And then I'll see your name here, okay? And then I should see this repository, I guess. And you have done something last week, right? Not today. So this is what I should. Okay, you don't have it, right? But it's the PDF plot, not the R script. I also need the R program. Yeah, so upload that on that repository, and then that's it. Yeah. So upload your R program also. Okay, so that's all. So now we should be good with this correlation. The last statement here is for Spearman, right? For ranked variables. We don't have ranked variables, so we can skip this. So the next thing what I want you to do is an assignment. So I want you to create a plot with correlation coefficient value for comparing columns. That's what you want to do. Okay. So do it, create a plot, save it a PDF, upload it on your Git, you're done.